Okay, fine. So Manoharji, welcome. We are discussing the Linux, and we had seen in a first class some of the basic I had discussed. Do you remember anything? Do you
Yes,
understand?
sir.
Okay, great.
Yeah, I understood.
And see, when we see the Linux in Broadway, like so here, you can see here you can see, like say we are having the program and
Program.
kernel and hardware. So basically what is hardware? Like say we are having the CPU, then we are having keyboard, we are having mouse, and then monitor, and like that USB devices. So we are having many devices that all comes under our hardware. But these hardwares are very complex. Hardwares are very complex. Reason being consider like say USB. So USB
Yes.
itself is a very complex device. Monitor, if you see any monitor, color monitor. So if you see
Yeah.
any color, if you see any color monitor, if you
Yes, sir.
see any color monitor, that will be very complex design. And moreover, like many companies are making the monitor, many thousands of companies making the monitor. So
Yeah.
each monitor need to handle in a different way. So we need to have some kind of software who can handle this kind of displays and this kind of hardware, which is like very complex hardware. And so for that, like what we are having one kernel code. This kernel code is handling the all hardware related complexity, and it exposes the system call. So what is system call? System calls, you can say it's like just like a function, but this function is written in the kernel. And if we want anything, if we want to do anything, read or write or any operation, if we want to do, we have to use the system calls.
The system calls.
Yeah. So who we means who? We means like programmer. So who we are
Program.
programmer? We are the application programmer. What's the meaning of application programmer? Say, consider you are already having one PC. Or PC may be broad sense. Consider you are already having the POS machine. Had you seen POS machine, point of sale machine?
Yeah, sir.
Where like
Yes, sir.
we are swiping your credit card and
Swiping our credit cards and
so
debit
consider
cards.
that machine, that hardware machine is already there. But you want to use that machine in your company, and consider your company is doing maybe some construction business, and you
Yes,
want
sir.
to use this machine into your company. So when you want to use this machine into your company, you need to write some software. This software will be running on top of this hardware.
Okay.
Understand? So this is the
Yes,
application
sir.
software. Like in Windows term, you already know. In the Windows, we are having like say MS Word, Excel, Paint. These all are the applications. So in the Windows side, we are already aware of this thing.
Yes, sir.
Understand, right?
Yes,
So
sir.
this is the like one top level picture. So like here one more simplified description of the user space. User space means it's like a less privilege space where, like, even if we make some mistake, not a big problem. It's okay, kind of thing, because it's a having not a very hi-fi, means not a huge writes. So even if you make some mistake in user space, it's not going to kill your system. So what happened in
It's
user?
like what it's like, sir. Like it's a code or we are writing anything.
Okay, consider like say if I show in a Linux environment, consider like say I am here, okay, and
Okay.
like if I say cd and if I consider like say we are having this one this test.c file is there.
Okay.
You see this test.c?
Yes, sir.
Okay, I'll make one copy of this. So I'll say the test.c and I can say like hi.c. So you see like now new file came hi.c.
Hi.c. Yes, sir.
So now I'm telling you, consider I want to remove this file. So how I can remove? I can say rm hi.c. That's all. If you see this file gone.
Yes, sir.
This we are in the user level currently. Okay. So we are having a excess of this file. But I'll tell you same now, I'll take you in the root level. So now I'm in root. Okay, I'll take you in some other file. Okay, and then I'll take you LSB. Okay, so consider I want to delete this init function. So if I say rm init, it will say remove write protected regular file. Okay. So consider if I say yes, cannot remove. Permission denied. Why this permission denied? Because like I don't have that access to delete this thing. My privilege level is less.
Okay.
Consider when you go in bank, up to certain stage you can go, and after that the bank people is not allowing to go forward.
Yes, sir. Yes, sir.
So same thing is here. I am not saying like we cannot do this. We can do this. But we have to change our level and we have to become root and we have to gain the power and then we can do it. Okay. So in Linux, so when you ask like what it is, when you say like when I say application program, then you say like what it is. Application program means what? So application program means it's a program only. It's nothing else. If you see in term of program, it is program. But that program having a rights or don't have rights. It's like that. So like in the user space, whatever we do, we are having the process and shell programming. I will take one day your brief class on this process also. I think you are missing in that. So that process and shell means in user space, whatever we do, that everything we are doing through the processes. So now this in the shell, what is shell? Just now we had seen the terminal. So this terminal is a shell.
Terminal only called shell on shell.
Yeah, it's like a shell program which is like enclose the entire your Linux kernel. We can able to send and read and write using the shell. Terminal only you can say. Actually, it's a bash shell. ASH bash shell.
Bash, okay.
So now the shell in the process, whoever is there, they both of them are using the library, signals, and system call. Using this, we can connect we can go to the kernel space. Say consider when you write program in C, and if you have to, I'll show you. Consider if you are writing in C and if you want to print something, if you want to write printf, what you do for printf? You just write printf and it will print hi. But actually, who is printing? You as a user space, you don't have access of the monitor. This monitor is in control of the kernel. You are writing this program in the user space.
Yes, sir.
But monitor is controlled by the kernel. User cannot display anything on the monitor. User does not have any rights. So whenever we give this command, behind the scene, system is using some system calls. Some system calls it using, and that system call, it display. Okay, so you can see here.
Sir, one question. What is the difference between system call and signals?
That I'll tell you. That is like both are different things. Signals, like when I'll tell you the process, you will understand. Signal is
Okay.
like, if I say, what you understand with this?
Yeah, it's in high like that.
So this is signal. If I say,
Okay.
then what you understand?
Yeah, done.
Yeah.
Okay.
So this is signal. What
Like
what's
it's
the,
like
what's
a
the context of this? Hmm?
it's like an acknowledgement or
No, many
like that.
signals are there. Many type of signals are there. Consider, like, say you are writing program. You are writing in the
Okay.
program and you make some program. You make one
Okay, sir.
program and you make one more program and you make one more program. 3 program you make, and all 3 program is running infinitely. Possible? Can you write while one, while one, all 3 program running infinitely? This is possible or not?
No, not possible, sir.
Why? I can make one C
Mm.
program and I can write while one here and run this program.
I'm both three are in one program only.
Not in
3
one,
times I'm calling the.
different program.
Okay, different means I can we can do, sir.
Yeah, so all are different program and I am running 3
Yeah.
program. Okay.
Okay.
When this program will be finished, when he will count till 10,000. Once his
Okay.
10,000 is complete, then this program will also stop.
Okay, sir.
But how he will come to know that he completed 10,000?
There is a condition.
No. This is one C program. So you can say like P3.C. You wrote separate program, main. You write separate program. Same way P2.C, and you wrote separate program. Same way you P1.C and you wrote separate program. This program, all are infinite loop, and they are running. Now I'm asking, consider we have to write such a way, like say temperature. When my temperature is higher than 35 degree, then he will send some message to him and he will turn on the AC like that. So this kind of thing is happened through the signal. So that I have to discuss with you separately. Like this is in the user space. This understanding we have to develop in the user space. Currently, our aim is more to talk about the kernel space. But what we are talking, this is more related to user space. So user space we'll discuss maybe in that won't cover in this course. So we'll see like what we can do based on that. I'll tell you some books that you can go through them and try to grasp it.
Okay.
Understand, right?
Yes, sir.
But do you have any? Do you understand little bit what I said? So just now,
yes,
once the temperature is more than 35 degree, it has to do something so that another process will come to know, oh my God, temperature is 35, like that. So this is called signal. Understand?
Okay,
right?
I got it, sir. Yeah, I understand.
So now we are having this. We are having the kernel. The kernel is using the driver. Kernel is using the driver to manage the hardware, because hardwares are very complex. Even the keyboard and the mouse, they are like very high speed interrupts, and like they are very complex device. The mouse which I connected, I can simply plug out. So they are the hot pluggable and very complex devices. So for that purpose, kernel is using the driver to manage them. Okay. And at the same time, from the user space, the system calls and signals is the procedure to talk to the kernel. Just I given you some time before one example where I told you, like say you want to print something high. If you want to print high from user space, you don't have rights to print user high. Then what you do? You use write system call. For that purpose, we are having the write system call. Using write system call, we tell kernel to do the hey, can you print the high? Kernel say okay. Then kernel use the driver, and then the driver goes to the hardware, and then hardware print the high.
Kernel to the driver.
Clear?
Yes, sir.
Okay, great. So this is the system call and the signals. Then we are having some network driver that is also driver only and related to the networking. The another view of same thing, I'm telling you the another view of same thing. Like say we are having the application. Using application, we are having the system calls. So the system calls is like mainly it's associated with the kernel in the application. This kernel is stored in the hard disk. Hard disk is a permanent memory. We are having a RAM because kernel or this cannot execute. Kernel execution is only possible through the RAM. So what we do is the kernel which is stored in the hard disk, we bring in
Hard disk.
RAM, and then we are using it. Since this hard disk is like maybe 500 TB hard disk or maybe 2 TB or 10 TB hard disk. Same way RAM is also bigger. So for that we need to have the management. Consider like say if you are having a 5,000 rupees. So you don't need any CA or something. But if you are having 500 crore rupees, then you need someone to manage that money.
Yes, sir.
You understand?
That like memory management.
Like same way memory management. If we are having some smaller RAM, no problem. But 1 terabyte of memory, 1 terabyte of memory. So then you can't handle yourself. You need somebody who can manage all these things.
Yes, sir.
And then we are having the hardware. We are having the hardware like display, monitor, DVD, USB. This all the hardwares are there. Okay. Then we are having the CPU. So CPU, now you see, like I'll tell you how complex is our how complex this entire system is. See, everything is stored in the hard disk. Everything is stored in the hard disk. Everything is stored in the hard disk, but hard disks can't execute anything. The execution happens through the CPU. Only CPU can execute. But CPU does not have any, means CPU can execute only through the RAM. CPU can execute only through the RAM. But whatever CPU has to do, that is written in the kernel. And the kernel is saved in the hard disk.
Sir, confused once again, sir.
I'll tell you again. See, the hard disk is a permanent memory. Hard disk is a permanent memory, right?
Permanent memory. Yeah, okay.
So the kernel is saved in the hard disk.
Hard disk.
Yes or no?
Okay. Yes,
The
sir.
CPU, whatever CPU has to do, it is written in the kernel. Whatever CPU has to do, that is written in the kernel. But CPU cannot directly talk to the kernel. CPU has to talk to the RAM. Means through RAM only it can access.
Okay.
Okay. So what
Yes,
happen is we are having complete booting up process, and in the booting up process, what we do is we take this kernel portion and the CPU read the hard disk, and then it will copy the content to the RAM, some portion of RAM. And then it start executing this portion.
Okay, sir.
Now, if he has to initialize the display, the CPU go and tell him to initialize like that.
Initialize.
But for initialization, we need some source code, and that source code is part of the
Source
kernel.
code is in kernel.
So what CPU do first, it take this code and copy first here in the RAM.
Right.
And then from RAM it execute so that this monitor is initialized. Same way for network, same way for DVD, same way for this. So you see, like each and everything is important, but each and everything can't do without each other. Like CPU is important, but he can't do anything with the RAM or kernel or hard disk. He can't, but with the help of RAM, CPU can execute. But what to execute is mentioned in the kernel.
In the kernel.
Kernel is stored in the hard disk.
Hard disk. Okay.
Okay. Since memory is this much is high, we need to have the memory management. Now, who do memory management? The memory management code is written in the kernel, but memory management code will be executed by the CPU. But where? In the RAM.
Okay.
I'll tell again. The memory management code is written in the kernel.
Okay, sir.
Kernel is saved in the hard disk. Obviously, right? Because no other place we are having. So the memory management software is written in the kernel. Kernel is stored in the hard disk.
Stored in the hard disk.
The memory management, who will do? The CPU has to execute this instruction. Only CPU can do, na? Kernel itself cannot do. It's a software. It's cannot do it. Like a dead kind of thing. Life, CPU is having life. But what CPU has to do, that is written here. Like
written in the kernel. Okay.
Kernel. And kernel is stored in hard disk.
Hard disk.
Same way, monitor. Monitor cannot do anything. It need to have one driver. That driver is part of the kernel.
That is stored in hard disk.
That is stored in hard disk. So what CPU do? First it take that portion of the code and write in the RAM. Because CPU cannot execute from the hard disk.
Yes, sir.
So what CPU do? It will take the code, bring it here, and then it will go and ask the monitor to initialize. So what will happen is monitor get initialized, and then same way go to the display and all other things. The same thing goes for the all hardwares and kind of thing. Making sense?
Yeah, sir.
Okay, great. We'll move forward. So let's start, and we have some more time, so we can further go ahead. And then, so I'm asking you to install the Linux either directly or using native.
I got everything, the link and all. I will install today night only.
Okay, fine. Now, going forward, we need to have the kernel code with us. Kernel code you can get through the kernel.org. So I will tell you like how you can get it. You can open the website and you can open the kernel.org. In kernel.org, you will get something like that. And then you can see here which one code you want. Little later, I will tell you the the meaning of all these numbers also I'll tell you. But like, see, latest one is this one. So you go to the browse. You go to browse, then summary here. And then you will get this command, clone command. So you copy this one. Copy this. And then you can say here, now you make one folder, you go in a desktop. So I already downloaded, I made one folder, I believe. Let me check. Kernel. Yeah. So I made one folder kernel. If you don't have folder, you can make using mkdir command, and whatever name you want, you can create the folder. I already created. Now what I want to copy the kernel source code from the internet. So this is the kernel source code, which is written here. What I did, I copy this command from here, cloning. I want to clone the thing. And how can I do? I can say here command git clone, and then whatever command, and just I'll say enter. Once I say it start downloading the code. I don't want to download because I already have code. But if you want to see what is happening in the behind the scene, then you can fire the command called stress, stress.
Yes, sir.
Stress.
Yes, stress. Okay.
Okay. So this will tell you the like exactly what is happening behind the scene. It will start executing and it will be telling you the one by one. I don't want code, but you download and store it. So I already having, so that's why I'm not doing. See, once you download, you will be getting something like that. Will be CD, maybe Linux, I believe. Yeah. So once you download, it will come something like that.
Sir, video was stuck for a while.
Yeah, I not told anything. I said like once you download, it will come like this.
Okay.
Okay.
Okay, sir.
So now we had downloaded the kernel. Once we are having the kernel, then we can move forward. You may not have this git command like git clone, then you may need to install it. So when you fire the git command, see, I am having the git installed, so it giving me like this. If you have not git installed, then it will tell you the it will give something like that. So he will say he not found the git. If we want to install, he will give one command. If you face problem, then you let me know. I will help you in that.
Sir, can I get all these commands in like LSCD?
You can note down, like during the class, whatever we are talking, you can note down and I'll tell you the meaning of them.
Okay, sir.
Okay, you just note down the name of the command and slowly you will be start using them.
Okay.
There are many commands are there, but you may not need all. Maybe 10, 20, 30 command is enough in the beginning. Later on, as much as you learn, you can make your own command also. Okay, so this is, we had downloaded the kernel. We'll go forward. We still have another 5 to 10 minutes. Now, when we download the kernel comes with some file and folder. You not seen. Yeah, this you can see here. You can see here when we download the kernel, you will see something like that. And this is your entire kernel. Just now we are so many things we are saying kernel. So this is what the